uh, the here's the continuation of what I'm explaining about the Tesla and why this technology, which is quite excellent, not become popular to many designers, is because when the silicon transistor was created, they have the weakest link is on the base side. If you will go back to a simple relay, let's say we will make a simple 12 volts relay, and there is a contact here. You can put maybe 220 volts DC here, and then go here, put some load. There's a load, and this is the positive, and this is the negative side. But only this is a 12 volts. But once you go to high frequency ambient, this 12 volt creating here create an energy that look like shorting it. It's not ionization, but it can have some way of going here and making short to the contact here. The same thing on the base. That's what I'm explaining, and that's why a lot of the popularity of Tesla designing like this, and when they have many electronics screens coming in, this kind is really interrupting the frequency of another frequency, is jumping to another frequency because of the ionization, the arcing thing, which always interrupt to the radio frequency or whatever frequency. So, and be difficult to tune up, like what happened to me. Take a long time for me to figure out how to do it. That's the actually basic problem. And you can, regarding this one for you, what's happening inside, I just explaining something for you to have, since I can give it without a problem. Like, let's say the IGBT. We go back to the IGBT is the best one. The problem when you are, if you want to actually, there is a chance one day IGBT can work. There is a chance from other designer maybe. If you go to the ambient, it's a high static thing, high voltage, high static. This IGBT start to create, it's like a capacitor. They have a built-in capacitor. They start to have a built-in capacitor here. They call it parasitic or whatever, but this one is become capacitance. This area from the gate, source, drain, so that's the problem, because this wire, it's like if you are connecting here, this is like an LC already, and then parallel and series LC. So this is a problem. So somebody must, but there's some way how to do it. Maybe some, I'm not good at IGBT to use the IGBT actually. But if you want, I give you some idea. Let's say this is the IGBT, and always there is inside there is a freewheeling diode always. But this one freewheeling diode, that's a freewheeling diode. It was there because of the manufacturing process that is really required to put there. But you must support that. You must put external freewheeling diode, which is a little bit bigger. So that's it. So in case there is a reverse polarity, I mean, this will not go to here. This is the gate. And another thing, you must put here the speed of reverse polarity. Maybe this one cannot. You must put some Schottky diode here. We call it, this is the pass diode, and here is the something like that, or Schottky diode. This is one basic, or you can explore it if you want. This is the load. So this will protect the immediate reverse of, I can explain later on, but not now. But this is, you can put it here just in case there is a very fast reverse polarity of something like ambient, etc. This will help, because this one will help you to delay. If there is a fast reverse polarity of current, this one will delay the power going in, so that diode have enough time to catch the reverse current going through here. So there is a delay. It can create a delay on it. Some designer putting this here, but it's up to you to experiment it, whichever. But honestly, it cost me a lot experimenting this thing. I have no success, and here is the positive and here is the negative. So it's up to you to experiment, since I know a lot of engineer, inventor, they have a lot of IGBT parts, but always to create a lot of back EMF, you must go to the same principle of Tesla, is the lowest resistance as much as possible. That's why, at the end of the lifetime of Tesla, before he keep using high voltage, before he is using a lot of high voltage, because easily, if you have here spark gap, and this is the coil, and this is the capacitor, you just have some stationary spark gap or rotary. It can connect on the right time of, if this the ambient, the space can withstand, it will can create a conduction here. But since this is create a lot of spike, so much spike using high voltage, etc., so he used a low voltage already, but using here a mercury contact, that is, if you can remember, that's the time you call it a liquid metal, it's a liquid metal. That's the time. After that, he's able to run a car with few batteries only, or maybe there's no battery at all, just starting. But he used a mercury contact and using a low voltage, and that's it. That's his last. I think that's where he already now he able to run a car, because at high voltage, using the only way you can go is a spark gap of stationary or rotary type of spark gap, but eventually it will corrode the tip, the contact point. But the mercury can maintain. That's why as well why Tesla using the high voltage, because it can, you can have a space gap on it, and you cannot use on high voltage creating a spike by means of low voltage. You cannot create good back EMF on that. So when he discovered about using the mercury contact, it's a physical contact on his patent, based from his patent. Now he create a low resistance with high back EMF but low voltage. Low voltage even at something like 100 volts only, or maybe lower than that. And then he create and then collect the ambient, and that's the part of the history, because he's able to run the electric car with few batteries only. That's what I can share, and because a lot of people are asking me and keep asking, repeating, keep asking, I'm tired, and maybe I need to tell you about this thing, so you can start experimenting without me, giving the classified information what I discovered. Okay, that's for today, and I hope you enjoy watching the video and learn something. And if you have some questions, just keep asking, but I think I don't have time now to answer all, but I think this is what you can get from me. Thank you very much to all of you. Thank you, bye.